My name is Andrew Ahn. I am the governance product manager at Hortonworks. I cover the Falcon project as well as DGI. Recently, DGI, we submitted a proposal, and hopefully they'll accept our proposal and our name, which will be Apache Atlas. So I cover Falcon and Atlas. I'm also here with Venkatesh. He is the architect for the program. You have to come off mute. So we'll get started. The few slides that I start with are background slides. So, if folks come in a little late, I think it'll probably be okay. I think after all these presentations, you probably know the background behind governance and Hadoop in any case. So we'll get started. So Hadoop, is there a way we can turn the volume a little bit down? Yeah, thank you. Hadoop is not an island. It doesn't exist in a vacuum. It exists in a larger context. There are other platforms. And really what we want to do with Hadoop is we want to make sure that it adheres to the same requirements and compliance needs that all the other platforms do, right? So you have very mature tools, relational databases, appliances. They all have to adhere to these requirements. Hadoop should do it too. It should be a good citizen, right? So you can sum up a lot of these compliance requirements in some pretty big buckets, right? So we can say that they have to adhere to these major themes. Transparency, right? Governance standards and protocols have to be clearly defined. You have to do things the same way. Reproducibility, you have to be able to reproduce a data landscape. And this can mean either the metadata or the actual data itself. Auditability, you have to show all the different events and be able to use that as evidence. And you have to make it consistent. You can't change the way you do things on the fly because of convenience. You have to do things in the same way or have a procedure to make this change, right? So this isn't that easy with Hadoop. There's a lot of different components. There are a lot of different projects that are being developed at different rates. And they handle these constructs slightly differently. What we want to do is we want to have a way to marshal all of these different types of projects and components in such a way that you can manage them easily. You can leverage them and get fast time to value in the enterprise that you do with all the other platforms in your data, in your enterprise data ecosystem, right? So that's exactly what we're trying to do with this project, Data Governance Initiative, right? We want to be a good citizen. We want to snap into this existing framework. I think if you were here for the presentation before, they talked at length about having this governance concept in the enterprise. Well, you can think about that in terms of a single application, but you can also think of that as many different platforms, right? It's very likely that you're not just using one monolithic tool to take care of all of your data management needs, right? So it's just the philosophy. We feel that our customers are going to necessarily use different tools, and we actually encourage that. You should use the best tool for your needs. You shouldn't be locked into one, right? You should have open standards instead of proprietary ones. You shouldn't have to be forced to migrate and import things in and out of things. We want to have a common standard, right? That's really what we're trying to do. And to get to this end more quickly and more efficiently, we've actually partnered with a lot of tools. I could use my pointer. Been wanting to do that all day. So we have partners like Aetna, Target, Merck, JP Morgan, and Schlumberger. Not traditional technology players, but they have enough Hadoop adoption for them to understand the needs of putting more data there, right? It's not a science project anymore. They're at this early adopter phase, but they're seeing the value. And we're making good progress along the lines of enterprise services in terms of stability, performance, operationalizing it with Mbari. One of the dimensions that we haven't addressed really is governance, right? So governance makes a lot of firms reticent to put sensitive data in Hadoop because they don't think they have the controls. And we realize this, and this is exactly what we're trying to address, right? So with those companies, they're helping us build out the capabilities specifically for those verticals. So when we release this new project, it's not going to be kind of a generic version 1. there'll be some areas where we need to improve and iterate on. But when we release this product, because we're cooperating and co-developing with these companies, we're going to put out a product that can be immediately used. In fact, these co-development partners, we actually meet with them once a week, and we coordinate our sprints so that we make sure that we're not blocking them, and they're actually rolling out products internally, in production, through these different iterations. So they're doing it at a very, very fast rate. And we know that we're doing this in the right way because they're giving us very frank and very frequent feedback, so we're able to improve the product quite quickly. Now, there's also two other players there, SAP and SAS, and they're helping us with this metadata exchange, making sure that we have a good way of storing this information so it's not proprietary, so it's not locked in one particular type of format that's used by only a few applications, right? So they're really aiding us in that effort, right? We want to make sure that we're democratizing this service. And all of this, let me see here, go over to the slide. And all of this is enabled by the stack that we're building here. This is the architecture slide. Venkatesh will actually go into the, a little bit more into the architecture, and you can ask questions about that. But this is just a functional slide that we have here. The thing that I want you to key in on is this area right here, the knowledge store. The knowledge store is just another name for our metadata store. And we really feel that this is a thing that's really going to drive this additional enrichment in all of the different components and help bring it together, marshal them together to be really easily consumable, stable, and governable, right? We really want to make this happen with metadata, right? So the key to this is the type system, right? So you may have heard in that previous sessions or other sessions today about modeling metadata, right? And there's all these different models. How do you model an energy sector versus a bank versus a retail operation, right? They have different ways to model their lines of business, and they're fundamentally different. So rather than building one humongous model that's going to be able to accommodate all of them, probably not very well, we decided to build something that was much more agile. So instead of building Noah's Ark, we built something very specific. We built something that could change and adapt to exactly what you needed. So it can adapt to a line of business, a certain department, or a whole industry. But we let the customers decide so they can build what they need, right? So the base of it is the ability to dynamically create different objects inside of our metadata repository. And these objects can be created dynamically as well as having different types of traits or metadata tags. And Venkatesh will talk about that in more detail. The takeaway is because we have this flexible store, this flexible type system, we can make our model match a business process, as I mentioned, but we can also match existing tools that many of you may already own. You've invested a lot of resources in terms of money as well as time and personnel and machines into certain types of platforms. We're not saying you need to get off of those. We realize that in a larger enterprise ecosystem, these things have their place. They have their strengths and they have their weaknesses, right? So we want to maximize the benefits of those, and we want to connect to them and allow the metadata to be exchanged. So we can match those formats, so when we need to do an import, it's very easy, right? So we can actually import the structure as well as the actual tags. So if there's a specific vocabulary or a specific taxonomy that's being used, you don't have to change it. You can keep using the same thing. And this exchange goes in both directions, right? So that's the big thing there. The other thing that we can do is we can actually because we can bring in whole models and whole taxonomies, we can actually do something really cool. So if you are, if there's certain types of compliance requirements that are specific to your industry, like let's say you do credit card transactions, so you're very concerned about PCI, we can use the exact PCI vocabulary that they use for the audits as metadata tags. So when you bring your data into Hadoop, you can tag it appropriately, and later when you actually have to do these audits, it'll be very easy. Consequently, you can also import the relationships, the various hierarchies. A customer has an account number, it has an address, it has an age. All of those things all those relationships can be maintained and reflected properly in the PCI compliance requirements. And then we can also match them with rules in our tag-based policy engine, so that now we can take these specific vocabulary words, these taxonomies, and then we can make them with very specific policy rules, so compliance is much, much easier, right? I won't say effortless, because that would be not true, but it'll be a lot easier. It'll be much further along. And while you're taking data from these traditional enterprise data systems and bringing them into Hadoop, it's a great opportunity to tag that data, right? You can put in retention policy. You can enrich that data with this taxonomy for future audits. And you can leave it in there as long as you need to, right? And if you migrate the data to maybe a storage dense cluster, you have hot storage and cold storage, well, you can also make sure that the metadata follows this within Hadoop. So this is a great opportunity to tag this information. You may need to do some housekeeping anyway. This is a good way to just get it together. It's a very efficient way to do it, right? Once data gets into Hadoop, it's much more difficult to do this type of organization, right? So you really want to tag on the way in, right? So just to go over some key capabilities of Apache Atlas, I talked about a few of them already, but we have data classification. So we have metadata exchange. We can exchange metadata from upstream systems or downstream systems or tools you may want to buy in the future. We have centralized auditing. We're able to capture all this technical and operational data and make it searchable. Later this year, we're going to make this also immutable, which means that you can't change it. So now you can use it as evidence if you have some kind of legal case, which is kind of important. And we'll also make this taggable. So now you can correlate with business classification your logs, which is very important, right? This is going to save a lot of time and a lot of headaches. We also have search and lineage that allows you to search for anything in the metadata stored in the logs. You'll be able to retrieve that information and get lineage. You know how that data came to be and what happened to it afterwards, right? And we'll show you a quick demo about that, how to walk through that lineage, all the different steps that occurred in that transformation. And then we have security and policy engine. And we'll talk more about this later. And if you have questions, maybe I can get help from my colleague back there who's running Ranger. But we're able to leverage Ranger to use their plugin framework across all the different components that they're building their plugins into. And we're able to leverage that by enriching it and having tag-based policies. So they're going to offer role-based policies immediately, which means that if you belong to this group, you get this basket of stuff. But what we want to do is we want to enrich that and add additional policies. So for instance, if you have something based upon geography, we want to have that too. So if Venkatesh can access some data in the United States, but he flies to Brussels, and he tries to hit that same data, there might be different policy rules here. There might be different privacy rules. Now, if he goes to Switzerland, there are definitely different privacy rules there, especially in the financial sector. So even though he gets right to those tables, based on geography, we can actually apply a different set of policies, right? We can do some masking or some other operations there, right? We can also layer on something based on time. So a lot of energy companies will lease data. They have a partner and they have a temporary lease, like a library book. You might borrow this data for a little while and you have to give it back, right? So just to make sure that we adhere to these requirements, we can put a time dimension. We can say, Venkatesh has rights to this data, but only for 90 days. Exactly at 90 days, we can stop access. However, if there's a process that's running, you know, it's a batch process that runs 4 days, you don't want to stop this at day 3 because, you know, you'd be in a bit of a pickle. So what you may want to do is let that process run, but just stop new access. So we allow that, right? So you have a lot of control. Another thing that you can do is use this policy control to fence out certain systems. So maybe your data scientists are doing all this great work, but they're beating up your production system. Well, if there's certain reserved times that you don't want them accessing this production data, you can actually do that. You can actually create a prohibition, right? And then talking about prohibitions, one of the last things that we're going to try to do around mid-year is we have this concept of prohibitions where we take certain data sets and we can do things such as create a rule to say they can never be combined, right? If you have some data that's partially obfuscated and you have some other data that's partially obfuscated and somebody wants to do a query, well, you can do things and figure out who those individuals might be. You can re-identify them. In order to prevent that, we can do something called a prohibition. Now, this is particularly interesting in financial records because if you have enough data sets, you can probably reverse engineer quite a bit of this masking capability. So we want to make sure that doesn't happen, right? We want to get into trouble there. And then lastly, as a preview, what we want to do is implement row-level masking. So this is pretty innovative, and this is only for Hive, and this is only a preview, so I just want to throw in a lot of disclaimers. But based upon a value of a cell, we're going to be able to mask that whole row. Now this is important, and it's better than just putting nulls in there. So if you do a lot of data science operations, in order to actually use nulls, you actually have to calculate averages for that dimension, and then put those averages in, and they actually constitute a null in data science. So rather than go through this headache, we basically get rid of the row. So if you have something like Tableau, some kind of visualization tool that sits on top of it, we can have these rules that say, for an HR table, all payroll over 50,000 euros, don't show it. When you go to run this visualization tool, that row won't even show up. So if you don't have rights to it, your view will be specific to that user. So between the role policy, geography, time, and this other cell level attribute evaluation, we can actually customize a view, a presentation for each user, which is pretty amazing, right? So we can do this dynamically. Right, that's what we're after. So some of these things we're going to be able to put in to our product at mid-year, and some of the other items, like the masking portion, will be a preview, right? We need to work out some of the performance requirements there. As you can probably anticipate, we have some work to do there. But we're going to get this out there so that we can get comments and really just get it to our customers as soon as we can, right? Okay, so just a quick overview before I turn it over. Data classification, centralized auditing, search, and the security policy. We accomplish this by using metadata to make sure that the other components already in Hadoop behave better and more effectively, right? So we integrate with Ranger, that's down here. And there's another box right here, data lifecycle management. That would be like migrations, replications, evictions, pipelines. So evictions would be like data retention, removing data in a timely fashion. That is covered by Apache Falcon. So rather than recreate some of this functionality, we really have the idea of building the thing that's not there, which is this metadata store, and then building deep integration to the things that are already there, right? So that's our philosophy, right? So if I can leave you with one more thing before we get to the more technical aspect of the presentation, we are working on this program called the Governance Ready Certification Program. So we worked really hard to get this metadata, right? We made this great model. It interfaces with your existing tools and models your business. You have a collection of your technical metadata as well as your business classification, right? So you can actually say, give me sales from last month in this region, and actually will point you to HDFS path or a very specific Hive table. So we have all this mapping, but why not use this for more than just governance, right? You probably have a need to do things like discovery and tagging, right? So you may want to interrogate your data that you got because of some merger, and you want to know if it has sensitive data in there. There are many packages out there that will do this for you, right? And certain fields that are pretty common. So in the medical industry in the United States, they have a concept of a PHI or PII. These types of things are pretty well defined and really well understood. So there's a number of outfits out there that can scan your data, identify this, and with a high degree of precision, tag these. So it saves a lot of time when you actually have to do this and do this in a permanent fashion. So when a human being actually looks at that, a lot of that work is already done. And you probably should have somebody, obviously, verify this, but a lot of this work is done. It's very, very accurate now. Now, if there's custom masking and pattern matching, you can train these tools to do that as well. So this really facilitates interrogating the inside of the data, right, as well as having the metadata outside. That's an area that probably isn't a great fit for Hortonworks to develop products in, especially things like visualization. We don't want to be a visualization company. So why not enable those types of companies to use the same metadata? The metadata that you've already stored, the metadata that worked really hard to get and kept current, that is now exchanging with stuff inside of Hadoop and outside of Hadoop, why not leverage it to do something else? So you can use that tool, so you can use the discovery and tagging tool, and if you found something sensitive, it will tag that new data set sensitive. It has PII information. It has the address of individuals in it. You need to do something special with that. And then when you actually go to do something like an ETL process, they will understand that it is sensitive. Now, they didn't build a discrete interface between those, but because they're using a common metadata store, they understand this, right? And consequently, you can have more than just two tools. You can have as many as you like, right? because we are open source, we are not encrypting your data to a proprietary format. You can encrypt it if you like for safety, but we're not putting it in some proprietary format. We don't keep it, in some special store. We make this completely available to you, through REST APIs, right? And everybody who gets the certification must agree to the same principles. They promise to be good citizens. They promise to read data from our metadata store, but also write back what they did, so that when the next process picks it up, they can carry on, and now we have a nice lineage between different packages, right? Outside of Hadoop, and then something that happens inside of Hadoop. You can actually track the lineage between different platforms, right? So we are really trying to give the metadata truth in Hadoop. And we want to integrate and share that with everybody who wants to share it, right? So there's other packages out there that claim to have complete end-to-end lineage in Hadoop, and it's true if you use only their application. The moment they use another tool, it becomes a problem. Now you need to somehow integrate the two, right? We understand that's a problem. Companies want to use the best tool for the job. We want to make sure we're not standing in the way of that, so we created the governance ready package. In the center is our metadata. That's the metadata truth we want to make sure all the vendors agree to, right? So if you know about this, you have lineage, let's say hypothetically, in a very important ETL tool that you might have seen today. If you go into HDFS and you do something to that file at a file level, you've completely destroyed compliance with that other tool. So what you're going to end up doing is building a lot of silos. And we're about taking the silos away, not building more silos, right? You don't want to build Hadoop for one single purpose. You have Yarn. You can use multi-tenancy. You can use multi-user, and you should, right? That's how you get really efficient use out of your Hadoop cluster, and we want to enable that even further with better governance, which is the controls, and it's all powered by the metadata there. Okay. All right, so we're going to get to the architecture piece, right? You there, Venkatesh? I'll go to the first slide for you.
Okay. So as Andrew said, the heart of the system here is the type system, and I'm going to cover the details of this. But we've built a very generic type system where you can define or articulate your meta model, whether it's Hive or something that's in mainframe or your MPP databases, and the way you get the data or ingest the data using Scoop or any other homegrown tools, and then either model that in Hive as tables or plain partitions or directories and files in HDFS. You should be able to depict all these things in the type system. And we largely hide how it's stored in the repository. All the types themselves are stored in a graph repository. We use Titan because of the Apache license, and it's pretty good. I've used this in Falcon. And the backing store, the adjacency list for the graph database is, you could use different storage engines. Berkeley DB, JE, and HBase. We support HBase out of the box for scale-out storing. So largely it's hidden, abstracted away from the end users. That's why the layering is the type system. And we have come up with a search DSL where it's very similar to SQL, which I'm going to cover again in detail. And it's tied to the type, right? We, of course, give you full text search, but you can actually search being aware of your types, which is very, very cool. And we also have layered specific things for Hive. So you could learn the DSL, and we have solved the navigation across the different types, relationships between different types and traits, and we have solved all that as search. But we also support higher layer API for specifically for Hive to start with, which I'm going to cover in detail. But we will add for others as well, and we expose all these things as REST API. So we also have the concept of a bridge, which I'm going to cover in detail when I speak about Hive. And the search, of course, it's pluggable. You could either use Solr or Elasticsearch. Both are in the open source. So let's look at the type system, right? At a high level, the type system, the types, data types are, you have a class, which is very similar to, what we have in Java. You could define a class. Class has identity and lifecycle. So for example, you can take a table, a Hive table, right? Hive table is a class, right? You can have struct, structure bag of things. You can define your storage descriptor or partition, right, as structs. A storage descriptor has your input format, output format, right, things like that. Traits are interesting, right? Traits are something like tags. It can have attributes, so you can have security clearance, right? Let's say you have an employee table or a department class, and you can associate security clearance with level 1 to 5, right? For certain class of employees, you'll have security clearance as 1, right? You could define PII as a trait within the system. So you can, the traits don't have identity, but they attach themselves to different classes. So you can have a column class, right, which if it's social security, you can have trait as PII, right? You can also have encode the type of the PII saying, this is social security, because if you have different ways of encrypting this data, right, you can have hashing for IP be different from hashing for social security numbers, right? We support all the primitives, and we also support collections, right? Because if you want to support columns, a set of columns for a given table, we support arrays and maps. So you can have array of classes, array of structs, and things like that. And this is your type, right? You define table as a type or database as a type, and then you instantiate that, right? And we have something called referenceable. You create this class and associate actual data. A table can be a clicks table, right? Employees table. Columns could be the name, creation time, yada yada yada. So I'm going to cover an example as well. I'm not sure if this is visible, but it covers different types. Essentially all the types as a class diagram here. Oops. So this is the longer version of Java. We have, most of the things are written in Scala. We have Java APIs and Scala APIs. We have builder classes in Scala, which is very, very simple. But if you look at, a table, the table is defined, we have some helper classes here. You can define a class type. So it takes the type, right? And if you have a super type, you can also have super types here. So you can have A kind of extends B, C, whatever. You can have a set of super types. And you have attribute, name is string, description is string here. You have a reference here, database, right? It's a database type which you have already defined, and you can refer to that as a database here, right? Or you can have a database with array of tables, things like that. So you're going to define this once, right? And register that as your type within the system. So very similar. I mean, you have columns here, right? We have columns, which is an array type here, right, of columns. So we support, various things, multiplicity. You can have collection. You can have, enum types. It's pretty extensive, actually. We're going to look at some examples as well a little later. So repository, as I said, graph is pretty interesting because, you can have discrete types but share some kind of common relationship. Like I was talking about traits. You want to also correlate technical metadata with business metadata, right? The taxonomy and the business glossary that Andrew spoke about can be modeled as traits here, right? With hierarchical relationships. And you can call something as sales within your ETL, but you can call the same thing as profit in your BI world, right? So how do you correlate those two things together? So you can have a relationship between these two. So that's the reason we use graph, because these interesting relationships and interesting attributes can be added over time, and these edges go from different vertices at different points in time, from different tools as well, right? So types and instances, both are mapped into the graph database. So if you want, the details essentially are, it's very simple OR mapping. I mean, most of us have used OR tools, so it's very similar to that. So type is, classes stand as vertices within the graph database. There are attributes within them as properties. And if you have, references to other classes, they go out as edges. Traits, again, are pretty interesting use cases where they are edges into different vertices that they point to, right? So search is, plugin enabled right from the get-go, because, some of our customers use Elasticsearch, some others use Solr. So it's pluggable, and indexing is based on the type annotations. You can actually define, when you define a type, you can say what is indexable, what is unique, you don't want to index certain things, you can annotate saying, I don't want to index this, and we don't index that. We also support full text search. So whatever data values have been there in each of the types, we index them, and you can search full text as well. We're going to cover in detail the DSL part a little later. Okay, right here. So the DSL is the most interesting part. It's very similar to SQL. So you can say for a given type, if you say from type, it gives you a list of all the instances that you have, right? When you say from table, it gives you a list of tables. So when you say from database, it gives you a list of databases in your system. You can have where clauses. You can say where name is equal to something, or or owner is equal to Andrew, right? You get all the databases or tables created by Andrew, right? And you can have clauses with and, or, conditions, things like that. You can also select certain attributes for a given type, right? You can select just the name, creation time, yada, 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 right? We also have this interesting loop expression, which we use for lineage. So remember, we are essentially exposing a DSL, but behind the scenes, it's actually creating a DSL for the graph, navigating graph, right? So loop is something that Gremlin exposes. Gremlin is a DSL for graph databases. So with the search DSL, we are actually translating into Gremlin behind the scenes without you having to learn Gremlin, right? So loop is something that is exposed. So if you want to traverse the graph with depth, whatever, we can basically use the loop expression, and we have certain name queries which hides this complexity from the user. So with path gives you the paths, right? So from the starting point, what are the paths that I can reach, which is what gives you the the lineage. And you can repeat this. You can do joins, very interesting joins. We also support joins between different types, right? That's the power of this DSL. So there are some examples here. I think I covered a bit of them. So where name is reporting, you can select name owner. You get name and owner for reporting database. This is another interesting thing. So DB has name is give me all the databases that has an attribute name, right, with some value. DB is JDBC access is is straight. So JDBC access is straight, right? I got this data from using JDBC. So JDBC access is some trait that somebody created an ETL word, and I can say give me all the databases that has the trait JDBC access, right? This is again a trait search where you say column, where column is a PII, right? That means give me all the columns that has trait called PII. PII is personally identifiable information, right? So this is a join. This kind of gives you the schema for a table, right? So table where name is sales fact, comma columns, essentially kind of joins these two and gives you the column definitions for this particular table, right? So this one is the same join, but it gives you attributes, right? It gives you name, data type, and comment, right? Which is what we haven't defined in our model. As I said, we also support full text search. So lineage, right? So lineage is an interesting thing. So what we have done is instead of creating yet another API, we translate lineage into search, right? Using the loop expression that I just spoke in the previous slide. But since there is a learning curve for our users, what we have done is we created name queries, right? We have created a higher layer API for Hive and others. So we have inputs as an API, as a named query, which translates to a Gremlin query in the backend, right? With the search DSL. So we have the similar. So basically, given a table, right? A table name, give me all the inputs for this. That means how did this come about, right? So it's basically kind of going back to provenance, right? When you say outputs for a given table, it's like lineage. How is this being used, right? Who are all consuming this data? So this is for kind of impact analysis. If I change the schema here, how is this going to affect all the pipelines and the data that is actually being used from this point on? And schema. Schema is again a name query which essentially translates to give me all the columns for a given table, right? So that's the kind of power. So if you want to add higher layer APIs, it's very easy. And behind the scenes, it's basically search DSL. So Hive integration. So we have this concept of a bridge, which are so bridge essentially allows you to suck up information, discover information in an external system, and register them in Atlas, right? We out of the box ship bridges for Hive. So essentially, if you have a Hive, Metastore running in your enterprise and you adopt Atlas, you don't want to start recreating all the data. So we give a one-time load where you run this bridge, Hive bridge, and it kind of sucks up all the metadata, goes to the Hive Metastore, understands what database exists, what tables exist, what partitions, columns. It gets all that information and creates metadata for you. Right? We also ship Hive data model out of the box. So we register the data model and register all the different data that's available in the Hive Metastore and suck it up into DGI, right? So that's something that we ship, and it's extensible. It's a plugin framework. We plan to support Storm, and other things in the future. But a lot of our customers use, let's say, Informatica, Adaptive. Adaptive is another, metadata system that exists today. So you could write, bridges for these different systems to suck up this data. Of course, once we have this metadata exchange where everybody speaks CWM. CWM is this common warehouse model. We will eventually support that standard so you can export everything that we have in DGI as CWM and also import CWM compliant metadata. Most of the vendors support that, and we will have support for that eventually. So that way, bridge becomes much easier and seamless. For execution, for Hive query execution, right, to track lineage, we provide Hive hooks out of the box. So it's a push model. We don't want to solve word hunger by going into every component and interjecting ourselves, but we kind of stay away, and it's if you want lineage, if you want metadata, you got to push that. We will support everything for Hadoop ecosystem by integrating and working across the components. So our first one is the Hive hook. So it's a post-execution hook, which is which we will integrate both in the Hive client, Hive CLI, and Hive Server 2. So whenever you execute a query, right, any user executes a query, we intercept it, get the query, the time it took, who executed it, where was this executed, and most importantly, the physical plan, right? Hive unfortunately doesn't expose a logical plan, but we take the physical plan, extract enough metadata about that, saying what columns were touched, what joins were done, what was the predicate, what was the filter, what was the projection on different tables, and we actually stick a query block out of that process node within Atlas, and we also ship out of the box model for this, so that you can do very interesting things later, saying, give me all the filters for this table, give me the most used predicate on this table, right? What are the tables that have more than 6 joins, right? Things like that. So it's pretty interesting. We are capturing all this metadata in DGI, and we ship this out of the box. So you could write hooks for Storm, any other thing that you have. We have our customers who are writing some hooks for legacy stuff that they are running, right? So you could track provenance into external systems as well outside of Hadoop. So the demo, we have created a model. It's very simple, very similar to Hive. There is a database, table. There is a load process, which is your processing, which is it could be a CTAS, it could be a scoop job, which is loading this table. We also have views, columns, and storage descriptor. And the traits we have is JDBC access, PII, dimension, metric, and ETL. I mean, if you know BI and BI world, it's it's pretty similar to what we have. So this is the instance graph in DGI, right, which is materialized. There are 2 databases, sales database and the reporting database. We have 3 dimension tables here, product, time, and customer. And we have sales fact table here, right? These are different columns. Some are marked PII, and there is a load process, which is actually taking sales fact and time dimension and creating, a daily materialized view, right? And there is another load process which takes time dimension and daily materialized view and creating a monthly materialized view, right? So it's just creating different summaries essentially, right? For the reporting, for enabling reporting from the actual sales database, right? Which is your warehouse. So this is the sample that we have for demonstrating this one.
So I see this really nice clock at the bottom. It says we have 2 minutes left. So we actually have 2 very brief demos we could show you, but I wanted to make sure that we're mindful of your time. So if you have any questions, maybe we could address them right now. And if there isn't a huge number, I can just jump to the demo for those who want to see it. So are there any questions I can address? Yes, sir.
How do you see this applied on the read-down processing, especially on stream? Do you expect to have first stage that tag the data according to your model?
Yes.
How do you see that? Yeah.
I take that one. Stream processing. How are we going to accommodate data ingest with stream?
Okay, that's a good question. So with stream, see what we're doing here is we're actually capturing the design, right? We're not actually capturing every execution, right? I'm not sure if I spoke about it. So the design, let's take Storm, right? That's what I know. I don't know other stream processing systems. So in Storm, you have the topology, right? We plan to capture, just like the query block, we plan to capture the topology in detail at design. Any changes, we'll version it and keep them so that you get a timeline view of your topology, right? In Hive also, we version that so that you get a timeline view of your data, your schema, and over the last 17 months, give me what all happened, right? You could have added a column, you could have did it. So all that we show. We don't have a UI for that today, but we will enable all that. So in your case, if when every execution of a topology, right, we will audit it. So I think we have 2 different components here. One is the design that we capture, and then there is audit of execution, right? So both will be correlated eventually. So the classic use case is this continuum of compliance. Is
Okay.
your
Well, that's one of them.
yeah.
Yeah.
So you want to capture what all happened over the last 7 years, right? Or between a time range. So we're going to show first the lineage of this, right? At that point in time, the latest one, and then show audit. If you're running your pipeline every hour or every day on a daily basis, we're going to show this audit of execution for this particular design that we have captured. Does it answer your question?
Yep. So maybe one other thing to add is, so we built, obviously we started with Hive because we thought that would resonate most with our customers, right? Especially if they're coming from an EDW world. We're going to add different types of hooks. In the meantime, we have the capability of creating a generic component that would just basically report into our metadata store. So interestingly enough, this generic component can live inside of Hadoop as a process, or it could be outside. So you can put whatever you want in our metadata store. It doesn't have to be something specifically in Hadoop. In fact, some customers, while it is very important that they have integration with Hadoop, they just want to put stuff in there. They want to have a business classification, a business glossary that is open source, that is not proprietary. Right? So any other questions? Yes, sir.
When is the glossary available?
Very good question.
Sorry, what?
When is it available? The metadata piece, and Venkatesh jump in if I'm mistaken, will be available through ASF soon. We've submitted the incubation proposal actually yesterday, so we're moving forward very quickly. So in the package that we're going to be putting in ASF, there'll be a minimum viable product which will have the metadata, so you can actually create
whatever you see in the demo is available.
Yeah, it will be available. It'll have documentation, and it'll be actually packaged a little more nicely. For instance, we'll have a server. Is it a server RPM we have? Okay, so we'll have a server RPM, another RPM for the hook itself for Hive, and then another RPM for just a client, so you don't have to install all the necessary pieces for the server. It won't install like TitanDB. So
Before midnight today, you'll have a source tarball. They were requested in Apache, so I'll upload a source tarball. It'll be available before midnight today. But from a product GA perspective, we will ship this as part of HTTP 2.3 in June.
Yeah, and that'll have the June release will actually have more features.
Ambari installation, all that will be you will have it. Ambari, RPMs, all the
So,
fancy pants.
Other questions? Yes, sir. The first gentleman in the green shirt, because we're partial to green, Hadoop and all that.
Thank you.
Yes, sir.
It's a it's a strange question because you're obviously biased, but how does it compare to Cloudera Navigator? Which I don't know.
We've
anything.
never ever gotten that question.
That's the first thing.
Maybe you can improvise.
So I'll try to be as fair as possible. Obviously, we are biased. You know, Navigator is a fine tool. It tends to be more forensic, which means that it really takes atomic components and reassembles them, right? It takes puzzle pieces and puts them back together to get your picture, right? Now, what happens if you miss half a piece? You will actually fail every audit that's serious, right? So, you know, while it may work for many scenarios, it definitely won't work for all. We're going to have that parity soon in our next mid-year release in terms of accumulating and collecting and searching that technical data. One thing that it's really missing is correlation to business data, right? Because you know, you can understand all these logs and all these cryptic names you might use for tables, but really you want the business context, right? Because without the business context, you don't know what the payload is, right? So what we want to do is we also want to take that business data and we want to make it much more proscriptive, right? We have this concept of a workflow that transcends multiple platforms. Do you really want to do audit in each platform and stitch it together? No. You want to have it together logically because this is the way your business runs, right? We understand this. The first slide we showed you was very indicative of what we're trying to do. We want to make this a first-class citizen in your enterprise, right? We want to make sure it does everything that the other mature tools do. And if it can do that, you're going to feel more confident about it, and you're going to be willing to put more data in. You know, and the questions will be more along the lines of, why can't I put data in Hadoop? Your first intention will be to stick it in there. And if there's a compelling reason not to do it, you know, then maybe you'll find an alternative, rather than the other way around, which is you have to go fishing for certain use cases that you can use this great new tool for, right? So we're going to flip that on its ear, and part of the way we're going to do that is actually tied to that question, which is this kind of proscriptive way of looking at data flows, really. We don't want to create more silos. We don't want to make Hadoop a black box, right? So, you know, Cloudera works with Informatica through this through a tool called XConnect, which you may or may not know about. And there's a number of videos on YouTube. I encourage you to look at it. And it's a great demo, provided you only use those specific components. The moment you go and you touch that underlying data with another device or another command line interface or whatever else, you know, you have to somehow deal with that, right? So the way you would accommodate that is to basically wall it off, right? Which is not really what you want to do, right?
So the technical answer is, you know, you cannot do provenance. You see, this gives you a lot more flexibility. We give a framework for actually creating types and associating. You have all the power, right? Of course, you need to do a lot of work. But if you want to do a column level lineage, let's say, you know, our customer, right, is getting data from DB2 into Hadoop through Sqoop, right? If you want column level lineage right from DB2 into Hadoop, right, and you're executing a lot of queries on this, you can't do that with Cloudera Navigator, right? It starts with Hadoop and ends with Hadoop. But you export these summaries like I was showing into a reporting database outside of, you know, Hadoop, you don't get that. But here you can model those things, right? Yep. And make it real. So that's the power. So one of the important things is, you know, people have problems looking at data and seeing, you know, how valuable this is, right? Or, you know, the example is if you have certain numbers on a particular day and, you know, it's off, way off certain other days, you don't know what the variance is, right? Getting all those measures and associating those measures with data is very, very important. What Cloudera supports is only, you know, tagging. But here you can, you know, you can model as complex, you know, a domain as possible.
We have Bert had a quick question. Oh, so actually, while Bert is coming over here, I said I promised I'd be fair. Bert is probably, I think, representing Informatica, if I'm not mistaken. And I wanted to do it justice, right? So while I personally am not thrilled with the concept of the XConnect, I am very happy with the concept of them collaborating with Hortonworks. That metadata structure that we talked about for the governance ready, one of the first partners that signed up to work with us is actually Informatica, right? So I have to be fair about that. And we hopefully will get that completed soon. And the idea is that we're going to exchange metadata with tools like Informatica because they use the CWM structure that Venkatesh talked about, right? In fact, we're actually going to connect to most of the big vendors. You'll be seeing a blog post about it very soon. There is a company that Informatica works with that also works with many other companies that's going to help us get there, right? So we're going to have a free open source bridge that's going to help us get there, right? So you have a nice, very profitable investment in these tools like Informatica. You can leverage Hadoop, and then we can actually tell Informatica about stuff that Informatica may not know about. You can do a search on Business Catalog and say, give me all the sales data, give me all those tables, and then you can actually create a graph around it, right? So thank you for reminding me to stay be honest.
The gentleman had
Oh, yes, sir. Another question, sir.
My question was how granular is the description, but I think you already somehow answered it. Is that a file and table level, or do you go to the column level, or how much work do you have?
How granular are we getting? So let's talk specifically about Hive, because you mentioned database and table. So we do get to the column level. The MVP, the minimum viable product we're going to put into ASF, will not have column level lineage. That's going to probably come around middle of the year. My colleague Balaji, who is the product manager for Ranger, will tell you that Ranger already has column level specificity in terms of writing security policies. We're going to leverage that work that's already been done by those guys. They did a lot of hard work. We're going to just kind of piggyback on that and add that additional functionality with metadata, right? Other questions? All right, so maybe we can get some more questions if you'll indulge us. So what you see here, and I get to use my green pointer again, is that the cursor is actually over this operation that was done. So this is actually a live demo, believe it or not, of a prototype that we whipped up in January. So the UI is actually not quite developed. Actually, we have another demo in the next tab that's going to be much nicer. But what this is showing you is that the data was actually pulled out of a mainframe, out of DB2on-Z. It was pulled out of there. They did some EBCDIC to ASCII conversion. They did some other stuff to it. They cleaned it up. It landed in Hive, and they did some predictive analytics. And this is for our partners. I guess it's not going to be a mystery, so it's already there. It's it now. So this is something that they're very interested in, that they were able to roll out. So they were able to have their own rendition of this. They actually added additional security features for their own use. But the guts of it, we collaborated on together, and we're able to do this. So this actually showcases a workflow that happened outside of Hadoop, ended inside of Hadoop, and we tracked it all, right? And as you see here below, you actually see the technical information that occurred. So if I scroll up, you'll get more information like query start time, query end time, and things like that. But I just wanted to show you that. Any other questions? So while I have you here and indulging your time, this is our new UI. So you can do searches such as DB. And what this is doing is it's actually going in there and looking, it's doing a type based on search. You want to talk about it some more?
I mean, as I went through the types, so essentially it returns the typed instances. So the UI is also type aware. So it's pretty interesting that everything is type driven here, right? You click on sales, you get sales details. We can look at a table. So this is basically translating to search, and all the tables that we saw. There are some dimension tables. There are some fact tables here. There are tags displayed here. If you click on sales fact, you get the details. Again, it belongs to sales database here, right? Some attributes, schema. As I said, it's a join in the search DSL. It returns all the column definitions, and they are basically displayed here. All the traits that we spoke about in the system are trait-based navigation here. There are different traits that I showed you in the class diagram. The lineage again is being worked on. We guys suck at UI. We will make it better.
Yes.
But if you look at it, you have load sales daily, which uses sales factors input, generates daily materialized view, which is consumed by a load process, monthly load process, and generates a monthly materialized view.
Yep. So one of the things that we can do is we actually because we capture that SQL statement, we can actually parse it and do some interesting things about it. Right now, we haven't built the smarts for that, but for instance, we have frequency of use based upon a particular user. We can actually show you frequency of use based on table, what types of joins they were done, and you can use this for all kinds of purposes, chargebacks, metering, whatever metrics you might want, or you can use this to do hot and warm, cold storage. If a table hasn't been accessed, you can create a threshold and a rule and move that data out of a production cluster. So there's a lot of possibilities there. So should we stop for more questions?
Yeah, so these are different dimensions, search on a dimension tray, it gives you all the dimensions. Yeah.
Yes, sir.
I've one kind which you also mentioned with Informatica is if someone is going to do command line manipulation of the table, are you going to be able to capture that as well?
Yes.
Yeah, that's not for everything, right? It's for the Hive hook. Yeah. Because of the Hive hook, because we're getting data directly out of Hive, we'll get that activity, which is pretty cool.
Whether you use Hive CLI or Hive Server 2, you will get that.
Yes, as long as you're interacting with that data through Hive, not through HDFS, then you're fine.
Even HDFS. I mean,
Really?
you have to use Hive CLI. Right?
Yeah. Other questions? Okay. Do you want to show anything else? I think we're way over time.
Yeah.
Well, folks, thank you for spending your last session with us. We really appreciate it. Thank you.
Thanks,
If you
guys.
have, if you have more questions that you want to ask us on the side, we're happy to address them. We're up here.